right, so we're in section 7.2 today. And we're going to talk about multiplying powers. And I want to start with an example. So we're going to build our rule based on what we see in a couple of examples that we do. So we're going to look at we want to multiply 3 to the 4th power times 3 squared. So what we're going to do here is remember that 3 to the 4th power means we're multiplying 3 by itself 4 times. So there's 3 to the 4th. And then we're going to multiply that by 3 squared. 3 times 3. And 3 to the 4th means we multiply 4 times. And 3 squared means we multiply 2 times. Well, how many 3's do we have there now? 6. So we have a total of 6. So 3 to the 4th times 3 squared equals 3 to the 6th. So let's look at another one. 4 to the 3rd times 4 to the 4th. Well, 4 to the 3rd is 4 times 4 times 4. And we're multiplying that by 4 times 4 times 4 times 4. Well, here we have 3 of them. That's what 4 to the 3rd means. And here we have 4 of them, because that's what 4 to the 4th mean. And how many total do we have? How many 4s? 7. That's 4 to the 7th. So do we see what's happening with those exponents? Not that hard to see, I hope. When we multiply powers, we add the exponents. So that's going to be our rule. And I'm going to add one little thing. Our powers need to have the same base. So here, both of these are 3 as our base. Here, both of these are 4 as our base. So multiplying powers with the same base, we add the exponents. That's our rule for today. When we multiply powers with the same base, we add the exponents. And the way we'd write that in symbols is we'd say a to the n times a to the m equals a to the n plus m. And if we forget how this works, you can always just write it out like this. Just write all your, 3 to the 4th, write all your numbers out, and then just count them all up. That will always work if you can't remember the rule. All right, so let's look at some examples. So we want to write as a single power. That means just do whatever the math is that the problem's telling us to do. 9 to the 5th times 9 to the 3rd. Well, we have the same base, right? Both of those are 9s. So we add the exponent. That's 9 to the 8th. And that's all we have to do. If we have negative 3 to the negative 2 power times negative 3 to the 10th. Well, my bases are the same. Both of these are negative 3. So we add the exponents. And we say, okay, we have negative 3 to the, what's negative 2 plus 10? 8. It doesn't matter that this is negative. We can still add them. All right, we good with that idea? Not super complicated. Most of our problems are going to ask us to simplify. And now, simplify is going to mean we don't want a 0 for an exponent, because anything to the 0 power is 1. We don't want negative exponents. That's what we talked about yesterday. If it's negative on the top, we make it positive on the bottom. If it's negative on the bottom, we make it positive on the top. And if we have the same power multiplied, with the same base multiplied, we're going to add the exponents. So we're just going to add, we're going to continue with our things that we can do with exponents. So we might have something like 6b to the third times 8b to the minus 8th. Well, when we have something like this, we're just going to multiply the numbers together. So 6 times 8 is 48. So we multiply the numbers together. 6 times 8 gives us 48. Here we have powers that are multiplied together, and we have the same base. So we say, well, 3 plus negative 8 is negative 5. That comes from multiplying those two powers. Well, now we say, oh, wait, I have a negative exponent here. Negative exponent on the top. We move it to the bottom and make it positive. And this would be our final answer, 48 over b to the 5th. And we're done. Questions there? Yes?
Why can't the exponent be negative?
It's not that it's not allowed to. It's usually we like to have all the exponents positive. And that was one of the rules that we learned yesterday is negative exponent on top is positive on the bottom. Negative exponent on the bottom becomes a positive on the top. That's one of those things like reducing fractions, and it's not that it's wrong. It's just, that's just the kind of the standard way that we do things. Hello, welcome back. Were you here when we had our new seating chart? Let me figure out where you ended up. You're next to Logan. Hello. Luke is not here today. All right, let's do another example. We're still simplifying. 4c times 3d to the 5th times 2c to the 3rd. We're going to do exactly what we did in the first example we did here. First, we're going to multiply all the numbers together. Well, 4 times 3 is 12, times 2 is 24. We multiply all the numbers together. I have a c and a c to the 3rd. Well, what's the exponent on this c if it's just by itself? That's to the first power. So I can think of this as c to the first power. So I want to multiply those two. That's the same base, c. Well, I get c to the 1 plus 3, so that's c to the 4th. I don't have anything else to combine with this d, so I just leave it written as d to the 5th. And I'm done.
Can you not combine the 4 and the 5 exponents together? Can you not add those?
No, because these are different bases. This is a c for the base, and this is a d for the base. Very good question. Make sure that the bases, the whatever's down here, has to be the same. Yes?
What would it look like if either the C or the D was negative?
So if it were something like, I'll just write it down. If we did our work, da 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 da, and we got 24 c to the 4th, d to the negative 5th. So then this negative in the top would become a positive in the bottom. We got c to the 4th over d to the 5th.
Okay.
We just put it underneath everything as a fraction.
So if the c was negative, it would just be 24d over 5, and the other would be c
Yes.
4.
Yep, that is exactly right. Okay. I'm just going to erase this. Let me get a bigger eraser here, and then we'll do, we'll talk about scientific notation really quickly. So scientific notation is a way that you'll see this in science to write very big numbers in a kind of a more compact way. So you might see something like 3 times 10 to the 8th, and we're going to multiply that by 8.64 times 10 to the 4th. Now 3 times 10 to the 8th, what this means is 3 with 8 zeros after it. That's why we write 3 times 10 to the 8th, because this takes a lot of space to write. And 8.64 means 864. And I'm moving the decimal place over 4. 1, 2, 3, 4. So this is 86400. Well, the rule for scientific notation is just like the rule that we just used for multiplying powers. Our rule is we're going to multiply the numbers. And we're going to add the exponents. So I'm going to multiply these two numbers together. So I get 3 times 8.64. And when I do that, I get 25.92. So these are, I'm going to say this is the part where we're multiplying the numbers. My exponents, 8 plus 4, is 12. So my answer is going to be 25.42 times 10 to the 12th. Now technically with scientific notation, you're only supposed to have one number in front of the decimal place. So if I move my decimal place 1 this way, I'm going to add 1 to the exponent. So I would write this as 2.542 times 10 to the 13th. I'm not super picky about this technically, how scientific notation works exactly. But your book will always do this, and in your science class, they'll probably always do this, where you have one number in front of the decimal instead of 2 here. But in general, for scientific notation, just like for multiplying powers, we multiply the numbers together, and we add the exponents together, have the number here, and then 10 to the whatever your exponent is after you add it together. That goes there. All right, questions? So just one rule today. When you multiply powers, they have the same base, you add the exponents. Okay. Our work for today, we're in section 7.2. Ten through 20 even, 21, 37, and 42.